second topic of your DeltaMath assignment, which was compounding, solving for future value. When you are looking at these problems, what you're going to see is the word compounding at certain intervals. So for example, this problem here says Dylan invested $7,200 in an account paying an interest rate of 2.3% compounded quarterly. Assuming no deposits or withdrawals were made, how much money to the nearest dollar would be in the account after 12 years? So in seeing that part talking about compounding quarterly, we know that there's a different formula that we have to use. So the compound interest formula is very similar to the basic formula. However, there are a few key changes here. So you still have your final amount. We're still looking at the principal, or the amount that you put in. It's still going to be 1 plus or minus, depending on if it's growing or decaying. Your interest rate as a decimal, but this time, because it's compounding, we're splitting that interest rate over certain intervals. So we're going to split that. We're going to divide that by n, which is the number of times the interval is compounded per unit t, and t again represents time. And again, another key change here is that you are going to multiply in your exponent by the number of times that you're compounding. So for example, our problem here says it's compounded quarterly. So we know quarterly is 4. So it's been compounded. Our interest rate is split over 4 intervals within the year. So we're going to, in our formula, our n value for this problem is going to be 4. Okay. So let's go back and pick out a few of those key terms that we needed, or values that we needed. So we invested $7,200. So that is going to be our principal. So our principal is $7,200. In an account, it pays an interest rate of 2.3%. So 2.3% is going to be our interest rate, but we're going to write that as a decimal. Right now it's written as a percent. So to write that as a decimal, that would be 0.023. It is compounded quarterly. Again, quarterly means 4. So our n value from our formula is going to be 4. Okay, so no deposits or withdrawals are made. How much money to the nearest dollar would be in the account after 12 years? So our t value is going to be 12. Okay, so going back to our formula, we've got all the information we needed. We have our principal, so we know that that's $7,200. We have our rate was 2.3%, but again, as a decimal, it's going to be 0.023. It is compounded quarterly, so 4 times within the year. So our n value is 4, and we're going to look at how long or how much money is in the account after 12 years. Okay, so we're just plugging those numbers in where they belong. So our principal, $7,200. It is growing. Typically, when you're talking about interest in a bank, that is money that you are collecting on top of money that is already in there. So we're going to keep it as a plus. Our interest rate, 0.023. We're going to divide that by the number of times that it's compounded. So it was compounded quarterly, so we're going to divide that by 4. And we're going to raise that to the number of times it's compounded for each year that we are compounding. So it's compounding 4 times each year, and we're going to look at after 12 years. So once you get that information in there, again, it's just a matter of plugging it into your calculator. So again, I like the Desmos calculator, so I'm going to go back to Desmos. And I'm going to plug this in. And again, just being careful of divisions and things like that. So it was 7,200. It was 1 plus. I like to go ahead and set up my division at this point so that I can put what I want on top specifically in the top, what I want on the bottom specifically in the bottom or in the denominator. So my numerator was 0.023, that was the percent. My denominator was 4 because it was compounded quarterly. And then in the exponent, we're going to put, it was compounded quarterly, so 4 times a year, and we're looking at after 12 years. Notice here that the 12 did not go up there with the 4, so I'm going to come back and go back up here with 4. And I'm going to parentheses, and now when I do times 12, it keeps all of that in the exponent for me. And I can see here that my answer is 9,481, and it was 0.007. Again, going back to the problem that we were working on, it does say to the nearest dollar. So we want to round that to a whole number. So again, looking at my value here, 98,481, that is a 0 after the whole number there. So we're going to keep it 9,481. And when I submit that, it is correct. Now I do need to show you another type of problem, and it is a compounded continuously problem. So you have seen the formula for compounding quarterly or compounding semi-annually or monthly or so forth. So again, that end value changes depending on how often you're compounding. When you see the term compounding continuously, that means every second, every millisecond, even smaller than a millisecond. So it is just continuously compounding. There's a new formula for that, and that formula involves Euler's number. So you may remember it, PERT. So this is, again, you're still looking at your final amount. We're still using principal, or the starting amount. You still need your interest rate, again as a decimal, still looking at time. The difference here is that it is E, Euler's number. So let's come back and look at our problem here. So our principal, so it says Abigail invested $29,000, so that's going to be our principal, in an account paying an interest of 2.1%. So that's going to be our rate. But again, our rate we are writing as a decimal. And it says compounded continuously. So this here lets you know that you're going to use that A equals PERT formula, or PERT is what we sometimes call it. And then assuming no deposits or withdrawal, how much money to the nearest dollar would be in the account after 8 years. So 8 years is our T. So our principal is $2,900. Our principal is $29,000. Our rate is 2.1%. which as a decimal is 0.021, and our time in this case is 8 years. Okay, so we're following our formula. So our principal, 29,000, times E, Euler's number, and we're going to raise that to 0.021, and that times our time 8. And like we saw in the last problem, when we're dealing with exponents, it's easier or better to put our exponents in parentheses when there's more than one thing going on there. To the DeltaMath graphing calculator. Okay, so this time 29,000. Euler's number, so that's the letter E. We are raising it to our exponent. Again, our exponent here, because there's multiple things going on, we have 0.021 times 8. We're going to put it in parentheses. So 0.021 times 8. So it keeps all of that in there. So we have 34,305.161 and so on. So I'm coming back to check. It says round to the nearest dollar. So again, that's whole number. So I'm coming back. So 5 is the last part of the whole number, and then the decimal, and then it's 1. So we're going to keep it as a 5. So 34,305. So 34,305. And then when I submit my answer, we're going to see that that is correct. Thank you.